long before machines learned to think. A human being taught them how long before computers existed. Someone imagined a world where reasoning could be broken into clear steps, followed carefully and repeated without error. That person did not build a machine. He built a way of thinking. His name was Muhammad ibn Musa Al-Khwarizmi. And even today, every time a computer follows instructions, his legacy is at work. In the early centuries of the medieval world, knowledge did not travel easily. Manuscripts were fragile. Languages divided civilizations. Ideas were often lost simply because they could not cross borders. Yet in one remarkable period of history, something changed. In the heart of the Islamic world, a belief took hold that knowledge belonged to humanity, not to one culture alone. Ancient Greek philosophy, Indian arithmetic, Persian astronomy, and Babylonian calculation were not treated as rivals. They were treated as pieces of a larger puzzle. This belief gave rise to one of the most intellectually fertile eras in human history, the Islamic Golden Age. And at its center stood a city built not just of stone, but of ideas. Baghdad in the 9th century was unlike anything the world had seen. It was a place where scholars gathered not to defend tradition, but to understand it. Where texts were translated, debated, corrected, and expanded. Here stood the House of Wisdom, a living engine of thought. Inside it, scholars worked across disciplines. Astronomy met mathematics. Geography met calculation. Practical needs met theoretical insight. Mathematics was not abstract curiosity. It was essential. Calendars needed accuracy. Maps required precision. Trade demanded reliability. Law required fairness. And fairness depends on clarity. Among the scholars working in this environment was a man who approached mathematics differently. He was not interested in clever tricks or isolated results. He wanted methods, ways to solve problems that always worked, ways to explain those methods so clearly that anyone could follow them. He believed mathematics should reduce confusion, not increase it. That belief shaped everything he wrote. Al-Khwarizmi lived at a time when mathematics was fragmented. Different cultures solved problems in different ways. Some relied on geometry, others on arithmetic. Some used tables, others used rules passed down orally. What was missing was unification. Al-Khwarizmi did not invent mathematics from nothing. He organized it. He took ideas from India, Greece, and Persia and wove them into a coherent system. Not by copying blindly, but by understanding deeply. His work was not about brilliance, it was about clarity. One of his most important contributions was his approach to solving problems involving unknown quantities. Instead of focusing on specific numbers, he focused on relationships. He described problems in words. He explained each step in full. He insisted on balance and restoration, ensuring that nothing was added or removed unfairly. This approach became the foundation of algebra. But algebra was only part of his legacy. There was something even more profound, hidden inside his work, something that would not fully reveal itself for centuries. Al-Khwarizmi believed that a solution should not depend on inspiration. It should depend on procedure. If a problem could be solved once, it should be solvable again. If a method was correct, it should always work. This idea seems obvious today, but at the time, It was revolutionary. He was describing something far more powerful than a calculation. He was describing an algorithm, a finite sequence of clear steps that leads from question to answer. Repeatable, reliable, independent of who performs it. And from his name, this concept took its name. Al-Khwarizmi never used the word algorithm. He never imagined machines executing his ideas, but he understood something fundamental about reasoning itself. That thinking could be structured, that logic could be formalized, that clarity could be preserved through repetition. This insight would quietly reshape the world. His writings spread far beyond Baghdad. They traveled across the Islamic world, into North Africa, into Spain, and eventually into Europe. When European scholars encountered his work, they struggled with his name. They Latinized it. They adapted it, and in doing so, they unknowingly named the future algorithm, the word that would one day define computing, artificial intelligence, and the digital age, all rooted in the ideas of a man who worked with parchment ink and careful reasoning. Pause for a moment. Think about this. Every search engine, every navigation system, every automated decision, all depend on algorithms, and algorithms trace their lineage back to a scholar who believed mathematics should be explained clearly, step by step, for human understanding. That belief still matters. Al-Khwarizmi did not seek fame. He did not write for glory. He wrote to solve problems honestly. He believed that mathematics should serve people, not intimidate them. And in doing so, he became one of the most influential thinkers in history, even if most people never learn his name. As work began to travel beyond Baghdad, it did not arrive as a sudden revelation. It arrived slowly, carried by translators, teachers, and students who sensed its usefulness long before they understood its full importance. Manuscripts moved across deserts and seas. They passed through centers of learning in Persia, North Africa, and Andalusia. Each time they were copied, they were studied carefully, not as sacred texts, but as practical guides. What made these works remarkable was not their difficulty, but their reliability. The methods worked. They produced the same results regardless of who followed them. That consistency built trust. For scholars, this was a revelation. Knowledge no longer depended solely on individual insight. It could be shared, taught, and repeated without loss. This idea quietly reshaped education. In many earlier traditions, learning mathematics meant memorizing examples or imitating a master. Al-Khwarizmi's approach offered something different. It offered general methods. A student could learn a process and apply it to many situations, even ones they had never seen before. This was the beginning of systematic problem solving, and it would change how humans approached reasoning itself. When Al-Khwarizmi's works finally reached Europe centuries later, they entered a world that was both curious and unprepared. European scholars were accustomed to geometric reasoning and rhetorical explanations, but they had never seen mathematics organized so methodically. At first, the translations were awkward. The language was unfamiliar. The ideas felt foreign. Yet the usefulness of the methods was impossible to ignore. Merchants used them for trade. Surveyors used them for land measurement. Scholars used them to teach students how to reason about the unknown. Gradually, the methods became part of European education, and with them came a new habit of mind. Problems were no longer approached as isolated puzzles. They were approached as instances of a general pattern. The goal was not to solve one case, but to understand the method behind it. This shift laid the groundwork for modern science. What truly distinguished Al-Khwarizmi's legacy was his insistence on clarity. He believed that every step in a process should be understandable. Nothing should rely on intuition alone. Nothing should be hidden behind cleverness. This philosophy mattered deeply as mathematics grew more complex, as problems expanded. There was always a temptation to rely on shortcuts. But shortcuts without understanding break easily. Methods without explanation cannot be trusted. Al-Khwarizmi's work resisted that temptation. He showed that complexity could be managed through structure, that reasoning could be preserved even as problems grew larger, that knowledge could remain human even when it became abstract. This balance between power and clarity would later become essential when reasoning left the page and entered machines. Long after Al-Khwarizmi's manuscripts were written, thinkers began to imagine mechanical reasoning, devices that could follow steps automatically, tools that could repeat procedures without fatigue or error. These ideas seemed fantastical at first, but they rested on a simple assumption that reasoning could be broken into clear, finite steps. This assumption did not come from machinery. It came from mathematics. It came from the kind of thinking Al-Khwarizmi had formalized. As centuries passed, the word derived from his name took on new meaning. What had once referred to a method of calculation began to describe any structured process that transformed inputs into outcomes. The concept expanded beyond mathematics. It entered logic, philosophy, and eventually engineering. By the time electronic computers appeared, the idea of an algorithm was already mature. Machines did not invent it, they inherited it. Computers simply did what Al-Khwarizmi had described long ago. They followed steps relentlessly, faithfully, without understanding the meaning behind them, and that difference matters. Al-Khwarizmi designed his methods for human minds. He assumed curiosity, reflection, and judgment. His procedures were meant to be understood, not merely executed. Modern machines execute algorithms at unimaginable speed, but they do not know why those steps exist. They do not question fairness or balance. They do not reflect on consequences. That responsibility remains human, and it is here that Al-Khwarizmi's legacy becomes even more relevant. Pause for a moment. Every recommendation system, every navigation app, every automated decision, all rely on algorithms, yet algorithms themselves are neutral. They reflect the intentions and understanding of those who design them. Al-Khwarizmi believed that clarity and balance mattered, that reasoning should be transparent, that methods should serve justice and understanding. Those values are not automatic. They must be chosen. His life reminds us that the most powerful ideas often begin quietly, written on parchment, explained patiently, shared humbly. He did not imagine machines thinking, but he taught humans how to think in a way machines could later follow. And that may be the greatest influence any mathematician has ever had. As the centuries moved forward, the distance between Al-Khwarizmi's world and the modern world seemed to grow wider. Ink gave way to print. Print gave way to electricity. Electricity gave way to digital signals. Yet beneath every transformation, the same idea endured, that problems could be solved through a clear sequence of steps. This idea became so familiar that it began to disappear from view. People no longer asked where it came from. They simply assumed it had always existed, but it had not. It had been constructed deliberately, patiently, by people who believed that thinking itself could be organized. When early mechanical devices were built, they relied on this assumption. They did not reason. They followed instructions. And those instructions had to be precise, finite, and unambiguous. That requirement forced humans to confront a difficult truth. If a process could not be explained clearly enough for a machine to follow, then perhaps it was not fully understood. In this way, machines became mirrors. They reflected the quality of human reasoning. As computing advanced, algorithms grew longer and more complex. They were no longer written for human eyes alone. They were written for machines that could execute millions of steps without hesitation. This brought extraordinary power. Tasks that once took years could be completed in seconds. Patterns invisible to humans could be detected instantly. Entire systems could be simulated before they existed. But something subtle changed. The separation between understanding and execution widened. Many people could use algorithms without knowing how they worked. Decisions began to emerge from processes no single person fully grasped. Complexity increased faster than explanation. Al-Khwarizmi's methods had been designed to reduce confusion. Modern algorithms sometimes increased it. This is not a failure of mathematics. It is a reminder of responsibility. Al-Khwarizmi believed that a method should be understandable. He wrote as if someone would read every step carefully and ask why it was valid. He assumed accountability. When reasoning becomes automated, accountability must be preserved intentionally. Otherwise, procedures drift away from purpose. This is why the human origin of algorithms matters. They were never meant to replace judgment. They were meant to support it. They were never meant to hide decisions. They were meant to clarify them. In education, this lesson is especially important. Many students encounter algorithms as rigid instructions to memorize. They follow steps without understanding their origin. When something goes wrong, they feel lost. But Al-Khwarizmi's original vision offers a different path. Teach the reasoning. First, explain the purpose of each step. Treat algorithms as stories with logic, not commands without meaning. When learners understand why a method exists, they gain confidence. They can adapt, question, and improve it. This is how progress happens. As artificial intelligence advances, the relevance of Al-Khwarizmi's philosophy grows even stronger. Machines now assist with decisions that affect lives, economies, and societies. The steps they follow are still algorithms, and algorithms still reflect human choices. If clarity is lost, harm follows. If balance is ignored, injustice grows. If reasoning is hidden, trust disappears. Al-Khwarizmi would have recognized this problem immediately. He understood that methods shape outcomes, that structure carries values, that how we reason matters as much as what we conclude. His manuscripts may seem distant from modern screens, but the connection is direct. The same commitment to structured reasoning flows from parchment to processor. What changed was scale. What did not change was responsibility. Every algorithm carries an assumption about the world. Every procedure encodes a judgment about what matters. These judgments should not be invisible. Al-Khwarizmi believed that mathematics should serve clarity and fairness. That belief remains a guide. As we stand in a world shaped by algorithms, it is worth remembering their origin. not in machines, but in human effort, not in speed, but in explanation, not in power, but in understanding. Al-Khwarizmi did not imagine the digital age, but he made it possible. As the modern world settled into an age shaped by machines, the name of Al-Khwarizmi quietly faded from common memory. His ideas remained everywhere, but the man himself became invisible. Few people using technology today could tell you where the word algorithm came from, or why it exists at all, and yet his presence surrounds us. Every time a device follows a sequence of steps without deviation, his way of thinking is alive. Every time a problem is broken down into smaller parts and solved methodically, his influence is at work. Every time clarity is preferred over cleverness, his philosophy survives. This is a strange kind of immortality, not remembered through monuments or statues, but through habits of thought. Al-Khwarizmi lived in a world without machines, but he understood something timeless about reasoning. He understood that thinking becomes powerful when it is structured, repeatable, and explainable. He believed that knowledge should not depend on individual brilliance alone, but on methods that anyone could learn. This belief democratized mathematics. It allowed understanding to spread beyond elites and specialists. It turned mathematics into a shared human tool rather than a guarded secret. That may be his greatest contribution. As technology advanced, humans began to trust machines with increasing responsibility. Calculations became automated, decisions became accelerated, processes became hidden behind layers of abstraction. In this transition, it became easy to forget that machines do not think, they follow. They execute what humans described. Al-Khwarizmi would have insisted that those descriptions matter. He would have asked whether the steps were fair, whether the reasoning was transparent, whether the method could be explained to someone else. These questions are no less important today than they were in the House of Wisdom. Perhaps they are more important in a world where algorithms shape communication, opportunity, and knowledge itself. Clarity is no longer a luxury. It is an ethical necessity. Al-Khwarizmi's legacy reminds us that mathematics is not neutral simply because it is precise. Precision can serve justice or amplify harm, depending on how it is used. Structure gives power, but intention gives direction. This is the lesson hidden beneath centuries of progress. Algebra and algorithms were never meant to replace human judgment. They were meant to support it. They were tools for reasoning, not substitutes for responsibility. When mathematics is taught without its story, it feels cold and distant. When its origins are remembered, it becomes human again. Al-Khwarizmi did not seek to control the future. He sought to explain the present. Yet by insisting on clarity, balance, and method, he shaped centuries yet to come. His manuscripts turned into textbooks. His methods turned into procedures. His procedures turned into algorithms. His algorithms turned into machines. And still, the original idea remains unchanged. Reasoning should be understandable. Knowledge should be shared. The unknown should be approached calmly. This is not the legacy of a machine age. It is the legacy of a human mind. As we look at glowing screens and powerful systems, it is worth remembering that their deepest foundations were laid by someone who worked with parchment and patience, someone who believed that mathematics should serve understanding. That person was Al-Khwarizmi, and in a world shaped by algorithms, remembering his story may be more important than ever.